Hey guys, welcome to another con support video. This one is on the distance between 2 points. You can use the distance formula to find this, or you can graph it and just find the relationships that exist in the triangle that make up that line that you're talking about. So there's a couple ways to think about distance formula. There's the fancy formula, which is what you see in all the books and stuff, which is this thing here. Distance is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. That's very fancy. It works. It's perfectly fine. I think it's a little confusing when you look at it because it's a bit overwhelming. I think an easier version of it is just to understand, since you already know slope and you know change in y, you know change in x. The easiest way to understand it is that you're basically looking at a triangle, right? And if you're looking at the distance between these 2 points here, you're really asking yourself, okay, well, let's make this the hypotenuse of a right triangle. What would the dimensions of that right triangle be? What are the 2 legs? And then we know that the legs squared added together are going to equal the hypotenuse squared. Well, in that case, right, the formula for it is first you got to find the change in y. Then you got to find the change in x. Then you got to square each of them, add them together. And to get the distance, you take the square root of that. That's it. So it's really just the change in y squared plus the change in x squared, add them together, and then take the square root of that sum, and you're going to get the distance from one point to another on the grid. That's it. So with that being said, let's give it a try and see how it all plays out. Let's go. So this first one here, we've got some points, 4, 7, and 2, 2. So I'm just going to put those points up here in purple, all right? And I'll show you kind of how I like to do this problem. So 4, 7, and 2, 2. You can think of this, if you like, if it makes you happy, as the first point and the second point. So you can think of this as x1 and y1. You think of this as x2 and y2. And you can plug it into this formula. You can do that. What I tend to do is this. I just ask myself, how far is it from 7 to 2? It's 5, right? Absolute value of 5. In other words, 7 take away 2 is going to be 5, or 2 take away 7 is going to be negative 5. So either way, it's the absolute value of 5. What would you add to 7 to get 2? You'd add negative 5. Now, since we're talking about a triangle, the distance is always positive. So whether it's positive or negative, you take the absolute value of it, right? So it's going to be very simple. It's just going to be 5, and we're squaring it, right? Now, if you square it, it's going to become positive anyway, so you don't really need to worry about the absolute value. I just like to think of distance as absolute value, and I know I'm looking at the distance in the triangle, right? So anyway, regardless of how you do it, if you do it in the formula, you do 2 minus 7, 2 minus 7 here, and that would be 5, and then 5 squared. If you do it the way I did it, 7 to 2 is take away 5, so take that, an absolute value, and square it, basically, so 5 squared. Either way, the change in y is very clearly 5. And so the change in y squared is going to be 25. So we know that that value is worth 25. So I'll put a little 25 here, okay? And then we do the change in x. The change in x is 4 to 2. Well, what would you add to 4 to get 2? Negative 2. It's distance, so it's going to be positive. So we're looking at 2, basically squared. What's 2 squared? 4. So really what we're looking at here is 25 plus 4, right? Because the net value here is going to be 25. The net value here is going to be 4. And so what's 25 plus 4? 29. And then you're going to take the square root of that, right? Because it's a squared plus b squared equals c squared, not a squared plus b squared equals c. So at the end of that process, you've got this, the sum of these 2 values is going to be equal to d squared, but you don't want d squared, you want d. So you got to take the square root of both sides. Ultimately, all you got to do then is take the sum of those and take the square root of it, right? So what this is 29, square root of 29 is the answer. That's it. So that's kind of the way I would approach it. So the next one. Okay, this time they're giving you these 2 points on the grid, right? So you just have to ask yourself, what's the change in y? What's the change in x, right? So let's erase the old point. And let's just figure out what our new values would be. So let's get rid of this. We don't care about this anymore. So what are our new values? It says that you got this dot and this dot. Well, how far down is it? Right, that's the change in y. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 units change in y, so that's going to be 8. And we're going to square that, of course. And then we have over here the change in x. Well, that's going to be over 1. So that's going to be 1 squared. So really, it's just 8 squared plus 1 squared, and take the square root of that. So that's going to be 64 plus 1, which is 65. So this is going to be the square root of 65. So we look at the answer, square root of 65. All right, let's do the next one. So here you've got no grid, no labels, nothing, but you still have these unit lengths, right? So working with those unit lengths, you can figure it all out. So let's do that. What's the change in the x direction and the y direction? Down 1, 2, 3, 4, 5. Yeah, that's about the right height, right? Okay, 1, 2, 3, 4, 5. So what's your change in y? 5. What's 5 squared? 25. Okay, change in y squared. Change in y squared. The change in x direction is going to be from here to here, right? So it's going to end up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is going to be 12 squared, which is 144. Change in x is 12, square it, 144. And then you want the square root of the sum of those two, right? So that's going to be 169. And so you just take the square root of 169, right? And that's the answer. Now, the square root of 169 happens to be a perfect square. 169 is just 13 times 13, so the answer is 13. All right, next question. All right, let's do the next one. So this one says, what is the distance between these 2 points? So I'm going to write these points up here. So -5, -6. And the other point is -3 and -8. And I just asked myself, how far is it from -6 to -8? It's going to be adding a -2, so 2. The 2 squared is what? 4. So your change in y is squared is going to be 4. And then how far is it from -5 to -3? Plus 2. What's 2 squared? 4. So this is just 4 plus 4, which is 8. So it's going to be the square root of 8. And that's your answer. All right, so for this one, you could identify the ordered pairs, or you could just count to see what the triangle dimensions are. I think it's easiest to count. So it goes from 4 on the y-axis all the way down to -5 on the y-axis. So it's going to be 4 plus 5, or 9. So what's your y squared? Your y squared is going to be 9 squared, or 81. Sorry, your change in y. Change in y squared is going to be 81, right? The change in y is 9, and then square it, you get 81. And then the change in x is going to be how far over to the right? 1, 2, 3, 4. So that's going to be 4. 4 squared is 16. So really you're looking at 81 plus 16, which is 97. Yeah, 97. So it's going to be the square root of 97. And that would be the answer. That is not a perfect square. So you're just going to put it in exactly as it is. Okay, here we're going to identify the number of unit lengths for the legs, and then use that to find the hypotenuse. Okay, so 1, 2, 3, 4 by 1, 2, 3. So the change in the y direction is 3. The change in the x direction is 4. It's going to be 3 to the second power plus 4 to the second power, and then take the square root of all of that. Okay, what is 3 squared? It's 9. So this is going to be 9. What is 4 squared? It's 16 plus 16, and then square root of all that. And that's going to be the square root of 25, and that's going to be 5. So the answer is 5. Now, you probably should have recognized that because this is a 3, 4, 5 right triangle, and I told you guys to memorize that. So if you have memorized your 3, 4, 5 right triangle, then that could be helpful in this moment as well, right? Pretty cool. All right, let's put that in. And then the last one, let's just erase this work here. The last one here, we're going to just do the exact same process. And I'm assuming at this point you don't need me to write this out. So I'm just going to do what I would show on paper. So I would say, all right, I'm going from -6, 4 to -8, 6. From 4 to 6, I'm looking at a change of 4 to 6 plus 2. So change in y is going to be plus 2. And then change in x is going to be from -6 to -8, which is minus 2. But either way, it doesn't matter because you're going to look at squaring those, right? So you've got your change in y, which is going to be positive 2, and it's going to be squared. So let's just do that step. 2 squared is going to be 4. You got your change in x, which is going to be -2, but you're going to square it, so that's going to be 4 as well, because -2 times -2 is positive 4. You add it together, you get 8, and it's the square root of that. So it's going to be square root of 8 again. Anyway, so you guys hopefully got the idea there. No matter what formula you're using, you're basically just looking at taking any line segment, making it into a right triangle, so you can break its movement into horizontal and vertical dimensions. And then once you have that, change in y and change in x. You have the side lengths of the legs of the triangle. Use those legs by squaring them and adding together, and you know that is equal to the final side of the hypotenuse squared, right? A squared plus b squared equals c squared. In this case, change in y squared plus the change in x squared must equal the distance between 2 points on a line. And that's how you do it. Stop that.